Hello, everyone. Welcome back to PamTen's YouTube channel. And in today's session, we'll be doing something very interesting. So, we'll be going back to our childhood and we'll look at some Pokemon data. So, if you're someone who's in their late 20s, early 30s, I'm pretty sure you would have watched the series called as Pokemon or Pocket Monsters. And you'd have remembered Pikachu, Bulbasaur, Squirtle, and all of the lovable Pokemon. So we'll work with this Pokemon dataset. So I have this dataset over here, CSV file, and I'll be doing some visualization with the help of Python. Since that is a CSV file, let me go ahead and import Pandas. So this will be the library, which will help us to do some data manipulation, data visualization on top of this. And I would also need the visualization libraries. So from Matplotlib, import pyplot as plt, and I will also need Seaborn. So I'll say from Seaborn import SNS. Okay, so that was incorrect. So I'll say import Seaborn as SNS because SNS is just the alias which we are giving to this library. Now that we have imported the required libraries, I can go ahead and have a glance at the dataset. So I'll say pd.read underscore CSV. I'll give in the name of the file. So here, the name of the file will be pokemon.csv. And I'll store the result in a new object called as Poke. And I'll have a glance at the first few records of this data frame. So these are the first few records. So you see that you have Bulbasaur, Ivysaur, and these are of grass type. So this is their primary type, this is the secondary type. You have stats with respect to different things. You have attack, defense, total power, what generation this Pokemon is from, and if this Pokemon is legendary or not. So these are some basic information about this particular data set. Now that we've looked at this, I'd want to do some visualization. So I'd want a distribution of the primary types of all of these Pokemon. So I'd want to know which type of Pokemon is most frequently present and which type of Pokemon is least frequently present. So for that, I can show you without visualization first. So this is the type 1 column. So I'll take in the name of the dataset. Inside this, I'll give in the name of the column, which is type 1 dot. You have a method called as value counts. And here, this will tell you. So water type Pokemon is the most frequent and flying type Pokemon is the least frequent. Now, you have something called as a count plot. So using that count plot, I can create a distribution chart so that I have the similar type of distribution shown in a visualization. So I'll say SNS dot count plot. Onto the data layer, I will map the dataset which I've created. Then I need to map something onto the x-axis. So onto the x-axis, I'll map the type 1 column and I need to set the order. So order, we can set it through the command which I had showed you earlier. So from the Poke dataset, I am selecting the type 1 column and order is basically coming from the value counts of it. And when I say index of this, I basically get the labels. So water will be at the top, then followed by normal, grass, bug, psychic, and so on. Now, after this, let me actually just go ahead and show the result to you. Okay, value counts. Let me convert this into a function. Now this will run properly. Okay, we do get this visualization, but this doesn't really look pretty. So let me give some proper sizing for this. So I'll say plt dot figure size or fig size, fig. So this will actually be figure. Inside this, the parameter would be fig size. And then I'll set the values to be, let's say, 12 and 4. Let's look at this now. Okay, this looks much better. And if I want to fit in the screen, So 12 and 3 seems even better. And let me actually give this a palette. So you have another parameter called as palette. Let me choose set 3 over here. And this is even prettier, isn't it? So here you have the type of this Pokemon, and here you have the count of it. So water type Pokemon is the most frequent, flying type Pokemon is the least frequent. Now, similarly, I'd want to see the defensive stats with respect to each type of Pokemon. So here, what I can basically do is, I will first show you how this can be done. Poke is the data set, and I'll say Poke dot group by. I would basically want to group this with respect to the type of the Pokemon. So I'll say type 1, and I've grouped all of this, and from this, what do I want? I would basically want the defense of this. So here I'll say DEFENSE. Let's see what do we get. And so defense. So what I'd want is I'd want the mean of each type of group. So here what I've basically done is I've grouped all of these Pokemon with respect to their primary type or type 1. And in that group, so for all bug type of Pokemon, what is the average difference? For all dark type of Pokemon, what is the average difference? For all poison type Pokemon, what is the average difference? So here I can basically store this into a new variable and call it as average stats. Now that I have it, I can just go ahead and make a plot from this. So I'll say average stats dot plot, and I would want a bar plot for this. Kind is bar. Again, I'll say plt dot show, and let's look at the result. So this is what we have. So I can actually sort this. So sort values. Now let's run this. So here this goes from smallest to highest. Let me set ascending to be equal to false. Right, so here you have the highest average defense for steel and the lowest average defense for normal type Pokemon. Again, I can go ahead and set a palette for this. So let me remove that. PALETTE palette. Let me see if we actually have a palette type over here. Seems like palette is not a part of this. So what I'll do is I can just set a color for this. So I'll say color would be equal to, let's change the color over here. I'll set it to orange. And you see that all of the values have been set to orange. Again, I can set a figure size over here. So I'll say plt dot figure. Inside this, I'll have fig size. I'll set it to be 12 and 6. Now let's run this, and you see this is occupies a much larger area, and this is how we've been able to visualize the different defense ratings for each primary type of Pokemon. Now I'd also want to see or compare the stats of legendary versus non-legendary. So here, legendary false means that it is not a legendary Pokemon. If legendary is true, this would mean that it is a legendary Pokemon. And for that, I'll use something called as a box plot. So I'll say SNS dot box plot. So data is obviously coming from cookie, and onto the x-axis, I'll just map the legendary column, and on the y-axis, I will map the total column, which is your total stats or total power, what you want to say. And after this, let me actually type in plt dot show, and this is what we get over here. So it seems like if the Pokemon is legendary, then their stats, your total stats are significantly higher to compare to when the Pokemon is not actually legendary. Really interesting observation, isn't it? Great. So, friends, this was it in today's session. We've looked at the Pokemon dataset and did some visualization, understood some insights from this dataset. So, if you want to learn more, do like this video and subscribe to our channel. I'll meet you in the next one. Thank you.